Okay, imagine for a moment a time in history where the concept of zero does not exist. Over 2000 years ago, that was the reality. Subtracting a number from another number itself had no meaning. There was no symbol to represent the absence of a number, and over the time as mathematics evolved, the concept of zero emerged. And it was often just represented as a value, as an absence of a value, as shown in these Chinese, what do you call it? It was absent of it, often just showed as a space in these Chinese counting rods. Historical records show that zero was written as a number, was used as early as the 5th century. So in India, just like with any brilliant idea, it quickly spread across the world and was eventually incorporated in numerical systems, while algebra for its use was developed like what multiplying or dividing by zero means, what subtracting or adding, and later on techniques to deal with the edge cases like dividing by zero, multiplying by zero, etc. Okay, then in 1965, we saw a repeat of this whole zero saga, only this time in programming. So imagine a programming language without null. I mean, to most people, that sounds absurd. And prior to 1965, there was a time when null still didn't exist. 1965, Professor Charles Anthony Richard Orr, who invented the quicksort and won a Nobel Prize for computing, was most likely sitting behind his computer and sipping on some cola and thinking by himself, how can I over-engineer this code in front of me? But how can I resist the temptation to put a null reference simply because it's so easy to implement? And this was later known as the billion-dollar mistake. It was the invention of the null reference in 1965. And at that time, Anthony Orr was developing the first comprehensive type system for an object-oriented system in Algol W, which was later the basis of Pascal. And his goal was to ensure that with the introduction of null, that it was absolutely safe. But null in most type systems weren't safe, and this led to innumerable vulnerabilities, system crashes, and which have probably caused $1 billion in issues in the industry. Yeah, but was it really a mistake? Let's find out. I mean, there's nothing inherently wrong with null, but most languages until now simply just did not model it correctly. So, I mean, JavaScript made it even worse. They introduced undefined as well. So you can have null, undefined, also zero, which in some cases I'll show that's also interpreted as null. And then you've got no value. Standard equality checks does automatic casting in JavaScript. So, for example, this is the perfect way to do it in most systems. But since most companies used linting tools that force you to use triple equality checks, you are kind of forced to do a null check or not undefined checked. And then since developers don't often know JavaScript properly or they're lazy, they do the third option, so if A, which often leads to bizarre bugs. So, for example, if A is 0, this would be a false statement, and this would not execute. How does JavaScript handle the absence of a value, So in ES6, at least, there's the null coalesce operator, which allows you to first check. Is it null? If it's null, default to some other value. And then also ES6 introduced the null check, basically, which makes life better. I mean, this is both TypeScript and JavaScript. It makes life better, but it's not enforced. So if you don't have a linting system that checks for this simply doesn't happen, and eventually you run into an uncaught type error like the one shown here. What about Java? I mean, Java's got a much saner type system, and in Java, you're often forced to do lots of null checks manually, like this. And if you forget your null check, you often run into a null pointer exception. Same bug. That's a company did an analysis in 2018 where they marked the number of crashes by exception type, and null pointer exceptions were right at the top of it. It was twice as many as runtime exceptions, which were twice as many as IO exceptions. And then since JDK6, various entities tried to solve the problem by inventing their own @not-null annotations. So I don't know if you can see here, but if you look at some of the code that's published by JetBrains, they check for @not-null annotations by JetBrains themselves. They've got SonarQube. There's one by RxJava. There's the Lombok @not-null annotation. NetBeans introduced their own one. Eclipse introduced their own one. SonarQube introduced their own one. Android has got their own @not-null annotations. And then JSR 305 tried to unify the standards. And you know what happens when you try to unify the standards? So here's some mandatory XKCD tags. There are 14 competing not-null annotations. Ridiculous. We need to develop one universal standard that covers everyone's use cases. And the result is you now have 15 competing standards. So, I mean, probably somewhere out there, there's code that has 15 different types of not-null annotations, and it will still throw a null pointer exception in some system somewhere. If you do see such a thing, please send me a screenshot of it. It would be very funny. Some in JDK8, Java introduced a thing called optional, and the funny thing about optional is it can still throw a null pointer exception. And also your code becomes very unreadable. So, I mean, if you look at the above example, it's not very clear what exactly is happening here. Now compare this with Kotlin code, Dart code, TypeScript code, where you can just do an optional null check and then default to some value. I mean, that reads a lot better than, a lot easier than the Java code. Okay, let's go back in history again. About 50 years ago, so Algol introduced what is called tagged unions. Tagged unions allows you to have multiple types per variable. So I'm showing a TypeScript example here where the type is both number and Boolean at the same time. So if it's number, if it's type number, do something, and if it's type Boolean, do something different. Then in 2011, Red Hat unleashed yet another JVM language onto the world. It's called CEYLON. The top type in the CEYLON type hierarchy is called anything. So anything contains two subclasses: object, which is the superclass of classes and interfaces, and then there is null, which only contains the value null. Since object and null are separate types, anything that's null can only contain the value null, and anything that is not part of the null class or the null set cannot contain null. So I mean, that would be like assigning a number to a Boolean. It just won't work. And then if you do a bit of Boolean algebra, so for example, object or null, and then you do a null check to see that is not null, then you'll have a non-nullable object. So by defining null in the type system as a separate set, and using the union of object and null, this is exactly how you solve the billion dollar problem. And this is exactly what Kotlin did. So in Kotlin, you have type with a question mark, and type with a question mark is basically type or null. So this type is nullable, and in Java, you would annotate it with @nullable. And then type without a question mark is a non-nullable type. And then Kotlin introduced the third type. So since Kotlin has to operate or interop with many platforms, which doesn't take null seriously or null safety seriously, you've got the, I call it the Schrödinger type, but it's actually called a platform type because it can be null or it's maybe null. You don't know. But Kotlin offers you three modes or three ways to handle this. Either you can do strict mode. Strict mode basically says you always have to do a null check on the platform types. In which case it won't compile unless you do a null check. And then the second option is only to give you a warning if you try and access something which might be null. So then your code already becomes a bit shaky. And then there's YOLO mode, which basically says do whatever you want. This is like Java. You just throw a null pointer exception if you hit anything that's accidentally null. Okay, well, null safety across platforms is already a brilliant feature. Let's quickly run through some of the other brilliant Kotlin features before digging into multi-platform itself. JavaScript and TypeScript allows you to make the user prototype, so you can kind of extend anything you want. So, for example, in this example, I extend the string object to allow you to call hello on it, and it would do something. Java doesn't allow you to do extension functions, so you're kind of stuck with Apache comments and all these util classes littering your code base. In Kotlin, it's pretty simple as well. It's just string.hello, and you're done. Just like Python, Kotlin allows you to override operators. I mean, you can override anything. If you can't use an operator in some class, you can even create it. So, I mean, unlike Scala, which allows you to create any operator with symbols, Kotlin decided that it'd be safer if you can only create operators that are similar to function names. So, for example, in this example, I'm overwriting big decimal plus integer. So if I say big decimal plus 1, it will actually compile and return something. So in the code I'm overwriting here at the top, it says big decimal, and then it creates a new instance of big decimal, and it actually executes it. Similar, big decimal plus, I can overload it a double, so then I can just plus a double, and the same with string. So I can just plus 2.0 in quotes, and it'll work. And then the infix operator allows you to create, as I said earlier, your own operator. So I've invented the YOLO operator here, which says big decimal YOLO 3.0. I don't know what it's doing, but I mean, you can do that. Typically infix is used for in the standard library for stuff like XOR and Boolean operators. You also see it often in DSLs. People write their own DSLs to be more natural language-like. JavaScript and TypeScript add string literals or string templates since ECMAScript 6. So you can do backtick, define your string templates, and then just $curly brace your variables directly into it. Kotlin is exactly the same. You can, except the difference is you have to use triple double quote, and you can also use dollar variable or $curly brace variable. And Java 15 finally caught up, and it has also string templates, but or string blocks. But unlike Kotlin and JavaScript, you're kind of stuck with string.format if you want to put values into it. I mean, it gets the job done, but it's not there yet. Kotlin opted for property access instead of putting getters and setters all over the place. This actually makes it easier, or makes the code cleaner. So in Java code, you'll often see classes with lots of getters and setters, which basically just expose a private value. In Kotlin, it's a property by default, and then if you do want to override the getter and setter, you can also do that. And by overwriting the getter and setter, you don't actually change the API for your class. Kotlin has named arguments, which allows you to either you can either call a function with the normal parameters, like in order, or you can call it in any order by just naming them. And you can even put default parameters on some of these arguments, allowing you to even skip some of them. So for example, if the first name was by default Pete, and I don't supply the first name here, it will default to Pete by default. Kotlin also has composition over inheritance. It just makes it a lot easier to implement delegation. It has some built-in delegation patterns like lazy. It has some observable properties. You can also delegate getters and setters to another instance. Typical use cases when you have a class that wraps another class and want to delegate getters and setters to a wrapped class. I've personally built a dependency injection framework using delegation. So, I mean, it's pretty nice. There's also smart casting, which basically gives a bit of common sense to the compiler. So if I know this thing is a string, because I just assigned a string to a variable, it's going to be a string. The compiler will know it's a string. If I've just done a null check on this, the compiler will say, oh, you've just done a null check on this. You don't have to do a null check on this again because I'm smart casting it to a non-nullable. Type inference. So Kotlin, you don't have to, I mean, Java's recently got that as well to some degree. But in Kotlin, type inference is pretty potent. So you just assign something to something else and the type is automatically inferred for you. I mean, it does reduce boilerplate code. Inline functions. So inline functions allows you to inline certain blocks of code. I mean, this is typically used in reified functions. So when you compile generics in Java, it strips your types out. Kotlin allows you to inline those functions and then use reified generics. So you can, that type T that gets compiled out on Java, you can still access in Kotlin. Immutable collections, this is a brilliant feature. It allows you to create collections, lists, arrays, sets, whatever, that are immutable. So one of the best practices in Java is to do defensive copying. So if you send a list to somebody, you have to defensive copy it in case that thing gets changed. Since Kotlin lists can be immutable, or they're immutable by default, unless you specifically say they're immutable, you don't have to do that defensive copying because the list can't change. Standard library, I mean, this is a brilliant feature of Kotlin as well. So it's got all the nuts and bolts you need to build a lot of stuff out of the box. So you don't need util libraries for JavaScript and Java applications. Well, most of those things are already built into the standard library. Coroutines, I mean, that's a talk on its own. Serialization and multi-platform is what I'm going to get to today. I mean, as demonstrated, the Kotlin language is null safe. It has implemented all the very easy ways to implement all the best Java practices without a boilerplate. It's quite a modern and deep language as well. Coroutines, which is a structured concurrency to help you do concurrency in a consistent, predictable manner across platforms. But what problem does Kotlin multi-platform actually solve? Okay, so let's have a look at large applications. So this might be a Fortune 500 company, a Fortune 100 company, might be a startup. So let's see. Most companies have a database and at least a backend. And the backends are typically Java, C#, or any other kind of backend language. Some companies still create desktop applications. I mean, I've seen companies still using Delphi. If this is a business desktop application in a Java space, sorry, you might expect something like JavaFX in here. And if you're doing some native application, you could be looking at Objective-C or Swift for Apple devices, or you could be looking at C++, Qt, or Python and GTK for your desktop application. If you introduce a web application to the stack now as well, you get to actually choose a lot of different things. So which build system do you use? Which framework do you use? Do you use React or Angular or Vue or Ember or Meteor or Mifril or Polymer or Relia, Lit Element, Micro HTML? So let's assume most large organizations have at least one or more web applications that are actively maintained, and they're often in different languages. So one might be JavaScript, the other one might be TypeScript, another one might be in Dart. So yes. And now if you start adding mobile applications to the mix, your stack gets pretty complicated as well. Okay, let's add a bit of color to this. Yeah, let's bring this to reality. So let's say, for example, this large organization has a backend application in Java and Spring. It has another application in Rust. I mean, maybe it's doing some kind of photo or video editing or processing that needs a bit more oomph. Then they've got a desktop application built in C#.NET, another one in Swift, and another one built in C++. And in the web space, they've got a TypeScript as React, JavaScript as Angular, and let's say, or Dart and Vue. For Android, they've got Kotlin, and for iOS, they've got Swift. I mean, that is a huge variety of languages, and you'll typically have a separate team for each of these. And then in between, you might have something like Swagger to generate, generate certain things that can be used across these platforms. But I mean, does that really solve the issue? If you want to, I mean, if I want to change, let's go back quickly there. If management asks you to implement a small feature, let's say you want to change validation on certain things or on some input, what's going to happen? The backend developers will have to implement it on the backend. Your database admin will have to implement a specific feature in the database. Your .NET team will have to go and duplicate that logic on the Windows desktop. Your Swift team will have to duplicate that logic on Mac OS. Your desktop Linux guys will have to implement that as well. And then on a web space, each web application will have to go and duplicate that logic as well. And the same goes for Android and Swift on iOS. I mean, what if one person could write that business logic or make that change in one place, write a test case for it, and then simply allow each team to publish an update instead of duplicating that business logic across all the spaces. And this is certainly already possible. So in order to do that, you have to build the whole platform in a single language or use a language that can transpile to the other languages. So JavaScript, you can do that with Node.js, Electron for the desktop. Your web is obviously already covered, and you've got Cordova, PhoneGap, and some of the other frameworks here. The issue with this is your Electron application is very heavy, since it's basically a browser that's packaged into a window. And on the server side, you've got a single-threaded application. And for specific use cases, single-threaded is just not going to cut it. And I was going to make a joke about JavaScript being vulnerable in the backend, but then Log4j happened in the Java world as well, so I'll keep quiet about that. What if we built the whole thing in Dart? So since Dart 2.12, you had null safety in the language as well. The only issue with Dart is that the backend frameworks are all kind of abandoned. So Angel, Conduit, these other ones are not really maintained anymore. If you were stuck in Angular Dart, I see Google just published a couple of months ago that Angular Dart is in maintenance mode. So they're not doing any further big maintenance on Angular Dart. And then on the desktop and web, you can use Flutter. And one never knows if that's going to go the same route as Angular Dart. It might not. So it's a gamble you've got to take. Is it possible to build the whole thing in Java? On the back end, Java is certainly a good option. So especially combined with Vertex, you're obviously going to get one of the fastest backend applications. On the web front, GWT is still around. I believe J2CL would be underpinning GWT3. I'm not exactly sure how well that project is maintained. And for desktop, I've looked at JavaFX. It seems to cover all the bases there. And then for mobile, Android, you covered. I'm not sure about iOS. I Googled a bit around and saw there's a project called Codename 1. I don't know much more than that. Okay, and then in the C# world, this is also possible, also with some limitations. I'm not sure if the Linux desktop is fully supported. On C#, you also have the benefit of Unity. Unity gives you the benefit to generate WebGL. So, I mean, there might be some advantages on the C# platform. Let's get to Kotlin. So on the Kotlin space, any Java backend you use will also be compatible with Kotlin. So you could use Spring, you could use Vertex. Vertex even has a Kotlin flavor if you want to go that route. Then there's Ktor. Ktor was built by JetBrains themselves, also maintained by them, and that is also my preferred framework for Kotlin backend development. For desktop, you could go to native route, Kotlin native, or there's also Tornado FX. Android and iOS, there's Kotlin mobile multi-platform, which allows you to share your Kotlin code between your backend and your front ends. And then on the Kotlin JS space, there's a Kotlin React thing that is built by JetBrains as well, also maintained by them. And then there's a pure Kotlin framework called Fritz2. So for those people who don't want to go and mix Kotlin and JavaScript, you can just write the whole thing in pure Kotlin. So for the purest amongst the people. So, I mean, Kotlin platform is designed around the ability to write some common code that can be transpiled to JavaScript as TypeScript and using Kotlin JS, JVM bytecode using Kotlin JVM, and then native code for iOS, Windows, Linux, macOS, both Intel and ARM, watchOS, tvOS, Raspberry Pi, and recently they also added support for WebAssembly. I'm not sure how mature that is yet, but that's also out there. Let's have a look at a practical example. So I prepared a code sample here. Okay, let me just stop sharing. Okay, so first things first. Over the weekend, I've built a server application, very simple server application in Ktor. Since I didn't have a lot of time, I also slapped something together last night in JavaFX or Tornado FX. And then on the JavaScript side for the web front, I built something in TypeScript, micro HTML, and ESBuild. So ESBuild is supposedly, well, from my own experience so far, I've seen it's much faster than Yarn and Webpack and all these other ones. So let's have a look at what I've done here. Okay, so I'm going to start up the server. And just like with any good demo, it's taking its time. Okay, so server is started up. I've started a web client on this side on ESBuild, and then let's start a desktop client as well. Okay, so the desktop client is nothing fancy here. I can add an extra lesson. So the project I've built is called Things I've Learned Today. Okay, so this JavaFX or Tornado FX thing is just for demonstration purposes as the second platform, so I'm not going to dig too much into that. But let's jump to what it looks like the JavaScript side. Okay, so the one I've just added on the JavaFX side is appearing on the web front end. I can add a couple more, and this thing is limited to only allowing you to add 3 more things I've learned today. So let's have a look at how this is built. Okay, so what I've mentioned earlier is that the ideal way to build such an application is to have a common module. Okay, so my common module has a common main, and in the common main, I've got a state. As you can see, I'm exporting the state into JavaScript. And since this is in the common main, it'll get compiled to each platform that I'm supporting. So if we have a look at index.typescript, you'll see this thing gets generated. It gets compiled to JavaScript, and it generates some nice TypeScript headers for you. So whenever I change something in the state here, Okay, and let's put that back on. The Gradle build -t basically runs in the background. So whenever you make any changes, it automatically gets compiled. I'll demonstrate that in a bit as well. So as you change your Kotlin code, your JavaScript code gets updated automatically. So you can just refresh something without going through the long build process again. Okay, let's give it a couple more seconds. And voila, there is the blah I've just added in the Kotlin code appearing in my TypeScript header. So if I delete that again, it should be a lot faster. And it's gone. Okay, so there's two different ways to implement things in Kotlin multi-platform. So this is the one way where you've got a module or a class that is compiled to different platforms. Then there's also, I mean, in the case if you want to do a HTTP call. So what you're doing in JavaScript is not exactly the same as you're doing in Java. So let's have a look at, for example, action as an expect clause in front of it. So this basically says the common class or the class action expects an implementation for both JavaScript and for JavaScript, for Java and JavaScript. So in this example, the Java one implements standard HTTP call with Java code. And if you go to the JavaScript one, you'll see that it is using window.fetch instead of the network request that's being done in Java. Yes, and then somebody at the back is screaming at me, but you can already do this with Swagger. And then I'm saying, well, yes, Swagger can do some of it, but can you do this with Swagger? Can you generate rules that can be applied to your front end, back end, mobile, and web at the same time? So I've implemented a simple rule here called a lesson limit. So let's go back there. You'll see this is not going to allow me to add any more. So let's increase that limit to 4 or 5. Give it a few seconds to build again. Now I should be able to add more lessons to it. I think I'm getting an error here. Oh yes, I've got to restart the backend. Since this rule is also applied to the backend, so you can't do a JSON post from outside to bypass the rules that says how many of these things I've learned today you can have. Still starting up. Oh yes, this thing gets wiped every time you restart. Okay, so now you can add up to 5 items, and if I restart the desktop application, you'll also be able to, well, you won't be able to add more because there's already 5 of them. Yeah. Any questions?
So, hi Jan, thank you. And wow, you know so many platforms. How do you get all that knowledge about those different platforms?
I code every day, so coding is a hobby for me. So besides the scuba diving and mountain biking, I also code. I try to get in a couple of hours a day of just building random stuff and exploring new stuff. And yeah.
Yeah, nice. And what would your advice be to the organization that have that all that users of the different platforms only use Kotlin?
I mean, if it's an existing organization of all that stuff, I mean, that's called technical debt. They've got to maintain that. They've got to maintain teams to keep all that stuff going. But if you're starting a new project from scratch, I mean, I would not recommend going that route. I'd say build the whole thing on Kotlin, and your life is going to be easier. I mean, if you're only going to build a backend application, a web application, JHipster might be fine. But if you've got to support desktop and web as well, as WatchOS and Raspberry Pi, etc., I mean, I would go and say, well, build the whole thing in Kotlin and compile it for all the platforms.
Okay. Is Delphi, is that the framework?
Delphi is very ancient. I mean, it's back in the days when Pascal came out. So
it's before my time.
Yes, but there's still companies using Delphi desktop.
Okay. And Spring is a widely used framework in combination with Java. And
yes.
Which framework is commonly used in combination with Kotlin, or does Kotlin not need a framework?
Personally, I don't think it needs a framework. I mean, many people do put Spring in there, but I personally just write my own thing or put Ktor in there, and it works fine.
Okay.
I mean, if you're used to Spring, by all means, put it in the backend. It works fine. I mean, Spring and JetBrains, they actually collaborate to make sure stuff works together.
Yeah. Okay. That's good news, I think. I'm not sure, but is there a Pokemon next to you?
Yes, Snorlax.
Snorlax. So you're a fan of Pokemon?
So back in 2018, I saw this in the shop in the Netherlands. So we were visiting in the Netherlands, and I saw it in the shop, and I bought it, and now I brought it back to the Netherlands.
Oh, he's cute. Okay, so let me check if there are any questions in the chat. No, I think not. Well, then thank you for joining us in this awesome Build Tech talk about JHipster and Kotlin.
I see a comment there about GWT. Yes, GWT used to be awesome, and I wish they supported Kotlin. That would be awesome. But yeah.
I see. There's also a Pokemon fan. Snorlax is the best.
I mean, you don't need GWT anymore because of Kotlin JS. If you're writing Java code, I mean, GWT still works.
Was that answering your question, Pierre?
I think that was more a statement.
Okay. All right. Well, nice talk, Jan. Mark said. Well, I think it was a very interesting talk, and you did a nice job, Jan. Thank you so much. So then it's almost time to finish. I would like to thank you, Jan, and Jacques, for your valuable contribution. And if you would like to be in contact with one of our speakers, you can contact them via LinkedIn. But I'm not sure, Jan, do you have LinkedIn?
I do, but I haven't updated it in quite a while.
So if people want to be in contact with you, how could they reach you?
I think get in touch with Leonie, and then she can forward.
That's also fine. We will put our LinkedIn in the chat, and if you like to reach out to us, you can find the link in the chat.